Jason Van Gilder, how are you, sir?
I'm doing quite well. Thank you, Matt, for having me out here today.
I know it seems odd, but I am really excited to speak with you because so you're the director of the Public Works for Middleton, correct?
Correct. I'm the Middleton Public Works Director.
Okay.
Held that position for about 4 years now.
Okay. And you guys deal with that's water infrastructure, that's wastewater infrastructure.
Yes.
It's not electrical, right?
So we don't do electrical. The city, the garbage bills kind of run through the city, but that's really a separate company.
Okay.
But we do roads, which is a little unique for the Treasure Valley. Ada County has a separate road agency from the cities. We do drinking water. We do.
You say Ada County has a separate road agency?
Correct.
Yeah. So you have ACHD, but you guys are in Canyon, right?
Correct. So there are separate little highway districts, but they don't. The cities still manage their own roads. That's a little different than Boise. Yeah. So.
Boise has 2 blocks of road they manage, though, right? On 8th Street. So it's where you can get like the taco, and it's like where Dawson Taylor Coffee is. Those 2 walking blocks, those are the only 2 blocks that the city manages. And the cars don't go on them. It's like you walk across. It's where like Ruth Chris is or Moon's. You ever go to Moon's?
Oh, yeah.
So Moon's upstairs, that's on 8th Street. Anyway, so you do roads?
That. Roads, drinking water, wastewater, stormwater. Parks, we take care of the city's buildings.
Gotcha.
I've got a great crew that actually does all the stuff. I just push data on the internet, but I've got people that do things.
I have people skills.
They're good people. Yeah.
What would you say you do there? Okay,
yeah.
People. Okay, so the thing, you knew a lot, obviously.
Yeah.
The thing that I'm really interested in, and got very interested in, I went on very fortunate to go on a water tour. I actually saw you present on it, and then you and I were actually on a different tour, both sitting in the back of the bus. We're like, hey, man, I saw you. But the thing that I've grown really curious about is how the Treasure Valley municipalities deal with their wastewater, because we are in a desert. Right. And you can just repeat that in your head. We live in a desert, man, and we manage water pretty effectively, but we know what ineffective management of water looks like in our surrounding states. And Idaho, more than pretty much anyone in the West, in the arid West, is really trying to get ahead of it. Now, obviously, developing communities like Middleton or say Star or other places have to deal with not just supplying water, but also managing the wastewater that comes out with it. And a lot of that water either gets put back into aquifers that we then draw on later, and there's a big system involved in that, or they get put back into our river systems, which need to be put in at the right quality, at the right temperature, all kinds of different things. And then that water is again utilized downstream, either hydrologically or for agriculture, and then goes in and out, and then finally terminates in other states in the ocean. So there's this whole system that's relying on like incredible efficacy and accuracy with management of these systems. And lest we forget, improper management of wastewater has been the source of pain, despair, disease, and incredible human suffering in every human civilization, like since the beginning of time. So not just is it important, like in the abstract for ag and power, but dude, if we don't do it right, it's all over.
Yes.
You guys have an interesting system. Help me understand, because you're also at the cusp of having to build a new waste treatment plant because Middleton has grown so much. So help me understand what your existing system is, how you manage all of this, and then why you're at the point where you absolutely need to build a new system.
Right. Let's start with some basic stuff, right? Most people in Idaho probably live in the county. They probably have their own little waste field, puts the wastewater generally in the shallow aquifer table. Nobody's really drinking out of that, so it kind of migrates its way through to the rivers.
And you're saying most people, as in like if I'm on septic.
If you're on septic, that's you.
Right.
That's you.
So I have a drainage field and it goes out there
and the water
and it drains
just
down.
kind of goes away. I'm
not pulling water off the first 6 feet of the ground I do have a domestic well, but it goes down 100 feet and it's pretty far away.
The soil does pretty well at filtering the water. Okay. So that's good. That works as long as they're pretty scattered and spread out. You put too many of those together, you start getting some bad stuff in the soils. Nitrogen really is what builds up pretty quick.
What happens if nitrogen builds up?
There's just too much of it in the soils, and
then you get blooms of different bacteria. Because nitrogen is essentially food, right? Yeah. So it's like food for bad things, and then you have bad things developing, and you get like boggy, nasty bacteria ridden nasty. So okay, great. So that's bad.
So once people start living together in groups, they kind of need to take care of their waste together, right? So that's largely what forms the cities around here is the need to kind of handle their utilities, they provide water for everybody and provide wastewater treatment for everybody. So to be able to live in somewhat close proximity to each other, houses
safely
on the same street, safely, right?
Got it.
So that's pretty usual. The usual way is that somehow got to the town ditch that then went to the river, and as long as there aren't too many people, and life was kind of okay. As cities got bigger, I was telling you before we came in. I'm as small government folks as anybody, and like to keep them out of that. But if the government didn't have its nose or fingers in wastewater, our rivers would be on fire, because they were really in the 50s, 60s back east. They were just polluting the rivers just too much that they actually literally caught on fire.
That was Lake Erie, right?
No, I think it was the river outside of Pittsburgh.
Oh.
The rivers, yeah. So it caught on fire enough times that eventually got the government's attention. That's where the Clean Water Act came from. That was about Richard Nixon's era. I think he actually signed the Clean Water Act. And it's really done great. What they did was they said anybody that's discharging into the river, we need to give you a permit and then figure out how to get you not discharging into the permit. So they cleaned up all the industries kind of first. They were the easy ones. The wastewater treatment plants are kind of next, where the cities send all their sewage. And so they've been on that for the last 40, 50 years. And here we are, as standards kind of get more stringent, where we are today. So,
and to your earlier point, I heard I was at a thing where Senator Jim Risch kind of gave that introduction, right? And he had this point that I thought was really a great kind of precedent. And he said, look, government should only be engaging in things that individual citizens cannot accomplish for themselves. Right. He was like, that's it. If the community can accomplish this or whatever, it's like, stay out of it. If you have a private, like nonprofit or organization, stay out of it. We should only be doing things, committing time, energy, and money as elected people to engage in things that people can't solve for themselves.
Yes. Yes.
And that's the wastewater, right?
That's what we are. Yep.
Gotcha.
Privatizing, and drinking water too.
Right.
It doesn't really make sense to have competing people trying to sell you drinking water in the front, because we sell it pretty cheap.
You're not looking to make a profit. You don't have investors.
That's the point of the government. We keep this money in their own separate funds. Wastewater has its own fund. Water has its own fund. They pay for themselves with what they're doing themselves.
So when you guys, you take in the waste, right? I'm sure there is a myriad of, first you have a mechanical filtration to physically remove things like wood or whatever might have gotten in there, right? Or
pretty good. Yep. You screen it first.
Yeah, screen it first.
Yep.
And do you guys have actually successive screening mechanisms? Like the first thing to take out something large, and then you go like all the way down until like we can catch a wedding ring. Do you have anything like that?
It's all pretty much at the front end. There are some bars that might take out the logs or something that happens to get in the sewers. But no, it's a fine screen at the beginning.
You ever recover a wedding ring or something like?
We haven't. I heard a story last year of they found a ring, a high school ring that somebody's wife had gotten so ticked off at him that he flushed it down the toilet.
Man, of all the things, it's like, what kind of relationship did that dude have with his high school? It's like, if my wife gets mad, to think she's like, I know the worst thing I could do to this guy is flush his ring. And it's like, first off, I don't have a high school ring. You'd have to flush my wedding ring. That's on you, man. Like, I don't know what to tell you. All right. So you have that initial screen.
That's kind of the stinky stuff. By the way, flushable wipes are not flushable. Okay. Just get that. If we can spread that message out, we've done some good here today.
Are you dressing up as a fatberg tonight for Halloween? Because it's the most horrifying thing a public work guy could come up with.
Yes. The fatberg is not good, but flushable wipes. We got enough pumps between your house and our treatment plant that they just get tangled up and are a mess. Yeah. Crews hate them. So that's out, and then kind of past that. So once we take out the stuff that
That shouldn't be treated.
Shouldn't be treated. That's not biological treated.
Sure.
Yeah. Then it's kind of a matter of feeding the bugs that are in there. The bugs get bigger and heavier, and then putting them somewhere where they'll settle out and sink to the bottom. And we kind of scrape off the stuff that floats and send that away. Scrape off the stuff at the bottom, set that aside, and then the stuff in the middle is actually what your target goal is. So you get that stuff out, and then you zap it with something at the end, either chlorine or UV disinfectant is what we use at the city, and that kind of neutralizes anything that's left. And then from there, we send it right back to the river. It's actually it's swimmable stuff. I don't know that I'd take a drink right out of that, but
and you could theoretically get it to the point through enough like reverse osmosis, filtration, things of that nature.
Yes, there are.
Yeah. Okay, so I feel like you glossed over like a ton of information. So if I may, once it goes through the mechanical filtration, you have this giant pipe that's biological matter. And the first step in engaging this is putting that into a digestive system where you have bugs that are like near starvation. They're like, oh my gosh, I have to eat this stuff. So you have this big churning mass where the biological organisms in there are chewing up all of the worst of the worst, right? Yeah. Once they're done feasting and they're like nice and big and fat, then that body of water is moved into a settling chamber where the bugs, nice and fat now, are allowed to just calm down and sit on the couch and they just kind of sink down to the bottom. And then things that might be really, what floats to the top that you guys want to get rid of?
There's some scum that's, but you take that off.
So you guys skim off the top nasty and you let the bugs settle to the bottom. And that means everything above the bugs, but beneath the scum is stuff that you can then move into an additional treatment mechanism, which could be chemical filtration, which is like, we're going to literally, like anybody who's ever zapped a hot tub or a pool, you're going to do something like that. So whatever's left in there that's really bad. And in that, are you still dealing with like a lot of biological stuff, like bacteria that's left over after the digesters?
Okay. Yeah.
Some stuff.
Whatever's sort of left.
Okay.
The UV that we use kind of neutralizes, sterilizes it, so it has a shorter shelf life.
Right. So you have the chlorine option where you dump a lot of chemicals.
We used to do chlorine. We moved away from that.
And the UV system is where you blast it with UV light. Essentially, you pump this stuff through a rotating chamber, and you have a light that's so bright it explodes the cell walls. Correct?
Sure.
Because I had a UV sterilizer for my big fish tank. I had this 100-gallon fish tank, and I was pumping it. I made a CO2 reactor out of a 2-liter bottle, and you know what I'm talking about? The yeast. It was like yeast and sugar, and the plants grew like crazy, but a bunch of algae grew too, because there was like all this. I gave it a ton of light, and it was like it turned all green, like you couldn't see anything in it. And then I got a UV sterilizer that pumped all of the water through and blew up the algae cell wall. So then all of the algae died, and then it was like crystal clear. It was like, man, and I grew plants that were so great. I would go trade the plants with a fish store for like more fish, because I was growing plants like crazy, because now the algae wasn't growing and all of that energy and CO2 were going into growing the plants, which is awesome. Anyway, so you used to do a bunch of chlorine, and now you do the UV.
We've switched UV,
Okay, great. So at the end of that process, you then have, what do you do with the stuff that's settled at the bottom? Because you can take that water after the UV sterilization.
Right now we put it in a big lagoon that we pump out every 3 or 4 years.
Okay.
Yeah.
Okay.
We're due to pump it out again. It's due. It's ready. But.
And where does that, do trucks come and take it? Like where does, so then they take it and they go somewhere else.
They go somewhere else. Yeah.
Okay.
Last time we pumped it out into some bags that kind of filtered the water through, and then took that just to the garbage.
Gotcha. So you essentially get through all of this filtration, all of this settling, all of this digestion, and then you're like, all right, let's take out whatever last remaining liquids we can get out of this. And then we take the final solids that have accumulated over like half a decade, you put them on trucks, and they go away. Okay, great. Talk to me about what, with some water you put back into the river, but you also have water. Okay, so you have two mechanisms of returning. It's my understanding you have two mechanisms of returning this water back to the world. One is going directly back into a river,
right?
And the other is effectively recharging the aquifer that you sit on top of.
Yeah, what we've got now, we've known that we've got some real strict phosphorus limits, which we'll talk about in a minute, coming up. So the city has acquired a number of acres right next to our wastewater treatment plant. We've set aside about 10 of those acres right now for a demonstration project or a pilot project to show that we can take the water that we're done processing and grow alfalfa with, which isn't really unique. Lots of people do that.
Sure.
The two things that are really interesting that we're trying to prove is that we can use subsurface drip tape to put instead of a pivot. Usually they're out in the middle of nowhere and they can pivot over a big cornfield.
Sure.
This we're using drip tape, which reduces our setbacks on the side. Might let us use it in the middle of the winter. And then the other thing that we're really innovative that we're trying to show is that we can put this water on in the wintertime when people aren't used to irrigating stuff.
Yeah.
And that the phosphorus will get captured in the top soil layer and then taken out the next year when the crops grow.
Oh, so you'll have hyper fertile soil.
Well, yeah.
And okay, so in the summertime, if you put the water out there, you're going to have a certain degree of evaporative removal of moisture, right? In the wintertime, you're not going to have that. But the alternative, it's going to go straight back down instead of going up.
Well, the crops are going to take up the phosphorus.
Even in the winter?
Well, in the summer. They're going to take it up in the summer.
No, I'm saying water. Because you're like, okay, well, it's 15 degrees
Most
outside.
of it goes down, yeah.
Yeah, so
in
instead
the
of...
Yeah.
In the summer, most of it goes down. But you do have some evaporation.
Right.
Like if you were doing a pivot, you have a lot of evaporation. I talked to this guy... Andrew Mickelson, who's a potato farmer. He farms a bunch of things from East Idaho. And they were working a lot to figure out what the respiratory rates were of their crops. Because they're like, okay, look, the whole point of spraying water out through a sprinkler is to get water into the ground. And the whole point of getting water into the ground is get the water to be taken up by the plant. Okay. So everybody's like, oh, we should just water. But in reality, what you really want is water getting taken up by a plant. And these things are not always tied together. So there's a question of, okay, in different types of soil, sandier soil or whatever, how much do you water? How frequently do you water? Where's the water being taken up most by the plant? Is it in the first foot of the earth or is it like 3 feet down? All these different things. And they figured out really, I don't want to say really quickly, but using hydrometers and then gauging the plants. They're like, okay, what's the most effective mechanism in essentially watering protocol for this type of earth and, to get this type of effect. So one of the problems is obviously during the summer, you will have some evaporative loss when you're spraying in a center pivot. So this tape that you're talking about, these are like tiny capillaries spread out under the topsoil.
Right. Yeah.
So there's like no chance of evaporative, like you're going in where the roots are. So you're not evaporating anything.
Right.
Dude, that's wild.
Yeah.
Is this something that they use internationally?
Yes. The tape isn't all that new or innovative. It's used lots of places. What's innovative is that we're using it for recycle water. So that's sort of the.
Is it also dependent on the type of crop? Because alfalfa, if you're growing alfalfa with it, then you're not really digging up the root. But if you're potato farming and you have tape, subterranean tape, then you probably rip up your tape.
Probably challenge, yeah.
So it's dependent on what you're actually growing too. Okay.
Yeah.
All right. So you guys are then taking this capillary style tape, layering it down in 10 acres across the area, and you're going to be pumping water in there during the winter, even though it's going to be freezing.
Correct. Well, we're trying to demonstrate what water we can pump in there. How much can we do? Kind of an experiment. Does it freeze up? We're having good success. We're showing we can get it. We can get some loading on there in the winter, and that it's capturing that phosphorus. We're not just sending it back into the groundwater.
Gotcha.
The soils capture that phosphorus, and then as the plants grow next summer, it takes it back up.
Because the concern with you have phosphorus requirements when you discharge it into the river, right? Like if you're just pumping to the Boise River, you have to have very low phosphorus because the buildup of phosphorus on municipalities will create blooms downstream and stuff.
We will. That's the challenge. Right now, we talked about the government regulating these things.
Sure.
They issue us a permit to discharge into the Boise River.
Currently, like today, you have a permit.
Today, I have a permit.
Right.
It was issued in 1999.
Okay.
So it's a bit ago, and Middleton was a little different. 25 years ago.
Sure.
It expires in 2006. They administratively extend it year after year as they're trying to figure things out. We are due for a new permit really any day now. We should see a draft of it. We know IDEQ is working on it as we speak. We should see it. And so we know we're due for a new permit. Our last permit has basically two parameters. We have biological oxygen demand and total suspended solids. and that's kind of it. We know this new permit is going to have a lot more requirements.
So the original permit that expired and then is being renewed only had two, like, don't let anything be floating around in here, and don't have this other stuff in here.
Which is more appropriate for 25 years ago.
Okay. But the new one, what's the new one going to have?
The new one, it's going to have a number of parameters.
Okay.
The one that kind of is going to drive everything is phosphorus. The phosphorus limits on the Boise River, they realized those were a problem, I think, in the 15-year go range. They did a study of everybody that's contributing phosphorus into the river, and municipal wastewater treatment plants are one of those. Farmers are another one. So runoff from roadways, whatever else, everything they could find. They came up and they published what's called a total maximum daily load study.
Okay.
So it's a report.
It's okay. You can just
copy.
Oh my God! Look at that binder.
So it's available on the internet, and they did this study. They got everybody together and agreed on what kind of limits would be appropriate for each entity discharging into the Boise River.
Sure.
And then kind of allocated that load across the way. So we know with pretty good certainty what our limits will be based on what's in that report. And so to give you an order of magnitude, phosphorus comes into our plant at about 20 parts per million. Our current process treats it down to about 5 parts per million. Our limit says we have to be at 0.3 in the winter and 0.1 in the summer. So
you guys have a lot of work to do.
We do.
You have to be 1/50th of what you currently are.
Yeah. Yeah. We got to get down there. So,
and this is a state regulation.
Yes.
So you, Jason, you have no say in this. The city council has no say in this. It's, hey, 0.1, I did not stutter.
Yes. Okay. This is state, federal. This is, and really the community. All the users in the Boise River got together and said, this is where we want people to be. So,
now, it's my understanding that the phosphorus level of the Boise River, were we to sample it right before Middleton, would likely be higher than the 0.1 anyway. Is that accurate?
Yeah.
Okay. Now, I heard this, and correct me if I'm wrong, but on the water tour, somebody brought this up, and if I was to understand the answer correctly, it's, look, the problem is we're stacking, right? If you just say, like, Boise's the start of phosphorus, if Boise puts in a certain amount, and then Eagle, and then Meridian, and then Star, and then Middleton, and then Caldwell, and every municipality along the way, even though they're all putting in just a little bit, that stacks and compounds on each other. And then all of a sudden you have this problematic, I don't want to say dangerous, but problematic for whatever reason, be it with, the water becomes cloudy, or it becomes dangerous levels of phosphate.
Yes.
You have,
remember Idaho Power talking about the bacteria in their dam, Snake River, that pulls the mercury out of the soils that they're trying to reduce the phosphorus.
I missed the mercury. So there's a bacteria in the dams that essentially encourages leaching out mercury.
Pulls the mercury out of the soils.
And we want the mercury to stay in the soil.
Right.
So that bacteria is bad.
Yes.
That bacteria grows with phosphorus. So if we have a lot of phosphorus, then we have the bacteria that then liberates the mercury out of the soil. And now we have a bunch of mercury in the water.
Sure. Yep.
Wow, man. Yeah. These things are wild. Anyway, so bottom line is that's kind of the nature of it, which is, we're putting in what would appear to be excessive restrictions on phosphorus, but when looked at when you're observing the entire system, it's important that each person contribute down to this level, because then you have, mercury water.
Right.
Okay. So you guys are trying to figure out how do we engage this phosphorus and get rid of this phosphorus? Correct. Because we have to be 1/50th of the existing regulation. Right. One of the answers then leads to, let's grow alfalfa and encourage the alfalfa to eat the phosphorus.
Yes, we've looked at everything. The TMDL report was written in 2015, which was well before I was here. I've seen the old files where Middleton was sending letters saying, boy, this is way too low for us. Can you do anything else? And this is what we end up with. So we're just there. Middleton was proactive all along the way. We built actually what's called a Rubicon gate in the Mill Slough, which runs right by our treatment plant.
What's the Mill Slough?
The Mill Slough is a water body that is largely a drain.
Okay.
It empties out right by our wastewater treatment plant. We went upstream and got a grant with the Treasure Valley or the Lower Boise Watershed Council. They helped us get a grant. And the idea was that this will back up the water. It'll keep water flowing at the same rate, but allow it to back up in the mill slough. As the ditch company comes along in the spring or winter, digs out the soils that are behind it, those soils will have extra phosphorus because it will have settled out there. We'll take that soil, spread it on some fields,
gotcha,
let it go away, and we can maybe get credit for the pounds of phosphorus that we took out that could then offset some other phosphorus somewhere else.
Oh, look at you. Look at you.
Oh, this is all before me.
Oh my gosh. Okay.
So
Anyway, so
that was
Rubicon Gate, Mill Slough.
Rubicon Gate was one way. We got all this land right by there. Can we put some plan to put water on there particularly in the winter when it's a little harder to get out? Can we just put some water on those fields that'll take that phosphorus that we were going to send to the river and instead send it to grow things with it. The phosphorus is great. It's needed to grow things. Let's do that. Natural treatment stuff. So we looked at those. We're still going on both of those, but we're also realizing that the treatment plant we have now just isn't the technology that's going to cut it to get us all the way to where we need to get to.
So with the volume you guys are dealing with, you're essentially saying like, look, we need to be 1/50th of where we are. We didn't decide this. We have no say in this at this point. We have to be 1/50th. And with the current plant, you're like, look, we can't do that. No. Maybe if we had 1 gallon and we had enough time, but at like, how many gallons do you guys move per day?
We move a little under 1 million.
Wow. That's a lot.
Not, it's middle of the road really for a treatment plant.
Oh, well, it seems like a lot to me.
Yeah.
Like how many acre feet do you guys discharge every year?
Oh, I don't have the math right in front of me, but
hang on a second. I have a very specific reason why I'm asking.
Yeah.
Hang on a sec. How many gallons of water are in an acre foot? Okay, come on. Okay, so 325,000 gallons of water is in 1 acre foot, which means you guys do roughly 3 acre feet per day, which means you do 1,000 acre feet per year.
Yeah.
Okay, great.
Yeah.
Here's a question for you.
Yeah.
1,000 acre feet's a lot of water. And that's water that you're, as of right now, I know you have the testing of the alfalfa, that you're putting it back into the river.
Yeah.
Which means somebody downstream's like, hey, here's our 1,000 acre feet of water.
Yes.
If you guys start diverting it to be recharging your own aquifer, is there a water user downstream that's going to be like, hey, Middleton, give us that water again? You're like, nope, we're storing onto this. Because again, it comes out of the system and then goes back to your closed loop of the aquifer instead of going downstream.
It does.
So who owns the water?
The technical answer to your question is that the municipals claim that the water they take out of the ground is 100% consumptive.
But it's not.
Yeah. So that's.
By the way, the Boise municipal does, I think, 30,000 acre feet annually. Yeah. Like, this is a lot of water that if our municipal plants, our municipal works start recycling it and reusing it and not returning it back to the Boise River.
Yeah.
That's a considerable water right.
It is probably not all that big compared to the amount that goes down the drains and the irrigation.
But we have water projects that are like Anderson Ranch. That's for like 25,000 acre feet every 3rd year, because Anderson Ranch has to fill up all the way before you get that like last 6 feet, right?
Yeah.
Like I'm stating these numbers correctly.
Yes.
Yeah.
Sure.
For argument's sake. Okay.
Yes.
All right. Well, look,
Okay.
you're not worried about it.
Yeah.
Somebody else can be worried about it downstream from you. Yeah. So what does it look like then? You're looking at these regulations.
We're looking at these regulations.
There is no alternative. Yes. I presume there's a financial penalty if you don't go along with it.
Yes.
Right.
Yeah.
And so now you're like, look, city.
Yeah.
This is it. We don't have a choice. We didn't make the regulation. We need 1/50th of where we are. We cannot accomplish that with our current infrastructure. we need to build a X number of dollar plant. How much is the plant?
Oh, big.
Come on.
We are probably 60 to 70 million for the first phase.
That's a big one. That's the first phase.
For the first phase.
There are 10 phases. How much? So all in, what do you think?
I think we're 120, 130.
I'm in the wrong business. I need to be in the wastewater.
Come on over. Wait, come on over.
I know, I'm going to build it for you. I'll do it for 100 million.
Well.
They want 120. I'll do it for 100.
Yeah.
Come on.
Yeah. No. So let's
parse it out.
Middleton has known this 2015, 2016. We went out there and they've been thinking about this. 2019, we did a full water system plan, wastewater system comprehensive plan that looked at how we're going to get there.
Sure.
We brought in a third part, or kind of switched engineers in 2020 to see if there was a different way that we could do it more cost effective. They came back and 2021 hit, and we're kind of really growing, and we're looking, hey, how many people do we really need to serve long term? As you design these wastewater treatment plants, they like to know that you've thought 20 years ahead.
Right. So if you designed it just for right now, whoever the reviewing bodies would be like, hey, man,
yes,
yeah, that's the number of people today, but tomorrow,
exactly.
So even if you designed it and made it for today's immediate consumption, they'd be like, no, you need to build in a buffer.
Yes.
Oh, so that's when people are like, they're overbuilding.
Yeah.
Because I have seen that online. Somebody's like, they're building something way bigger than we even need.
Yes.
You're required to do that.
Yes.
Oh, that makes a lot of sense.
Yeah. But let's temper that a little bit. So we looked at what growth projection could be in 20 years. Sure. Middleton has essentially doubled the last two decades. 2020, we were just under 10,000 people. 2010, we were just over 5,000 people. 2000, we were just over 2,500 people. So we do have a history of doubling every 10 years.
Star went up 140% in like 5 years.
Yeah, it's not unrealistic. Nobody's really moving.
Are you guys close to Star? Is that are you in the path of progress? I'm just curious.
Yes, we are next.
I'm not good with geography. Is like Nampa? No, Nampa's not in there. Oh, it's just you. It's your next door neighbor.
Yes.
Okay, great.
Yes.
Keep going.
So yes, we looked at, we could realistically be at 40,000 people.
Pretty fast.
By 2040, which is a big number and is kind of a scary number when you look at that stuff. So we did responsible things and looked at how could we really accommodate that, and how can the plant be set up so that it can get to those number of people.
May I ask a question? Yeah. What's your population currently? You were 10,000 in 2020?
We're about 13,000.
Okay, so you're not quite on the doubling path this decade.
Not quite, although
you'll probably end up like 17,000, 18,000 or something.
It's not impossible, right?
Yeah,
and 40,000 may not happen at 2040.
But I mean, the point is, you even if you hit 30,000, it's thrice what it was in 2020.
And Compass thinks it's 40,000 maybe in 2050 something. Gotcha. So it's eventually come. It's there. So we looked at that. We looked at a number of different options, treatment alternatives. What do we do? Do we want to add more chemicals? Do we want to do a membrane plant? Do we want to do an enhanced biological nutrient removal, which is what we kind of settled on after we got as much input as we could. And so we picked that plant. We've got some really great operators down there. If you ever get out there, if you ever get out of the office, come on by. They love giving tours of their plant. And
like as ridiculous as it sounds, like I very much enjoy learning and seeing all these things with my own two eyes. Because you can talk about it in the abstract, but when you start talking about enhanced biological filtration, nutrient removal, like, is that like a bunch of mangroves? Like, how are you? What are these organisms that are just chewing through this stuff? And what do you do with them once they're done? Like the alfalfa makes sense to me. It's like, look, put the nutrients in, harvest the alfalfa, get rid of it. Then you have the other digesters where like, wait, they just get fat and sink to the bottom? Like, how does that work? And I always wonder, like, where did they come from?
Yeah.
Right? Like who's the pharmacy or the nursery that's supplying you with these like starving digester organisms?
Yes.
And like, are you growing tilapia in there anywhere? Because everybody knows like tilapia likes dirty water. You know, like maybe that's a thing. Like I would love to see it, because once you see it, you're like, oh, this is why this is so expensive, and this is why we need all of this stuff, because like all of the inputs and all of the ways of keeping this running, so that, by the way, it works pretty much forever.
Yeah,
it's like, that's wild. Just say, I'd love to see it. Yeah.
So we looked at the plan. We've got a plan for what it would take to get to that 40,000 people. We've also saying that it's not going to have that many people tomorrow. So what do we really need to build right now? And then what can be added on in a couple phases?
Gotcha.
We really
start with a single wide, you add the double wide.
Bingo. Yep.
There you go.
That's it. You need 4 clarifiers eventually. Right now we're going to build 2.
Gotcha.
You need 4 big basins to feed the bugs and let them grow and whatever they do. We're going to build 2 of them right now. We need this primary clarifier that kind of does the same thing at the bottom, except it takes the stuff off the very front end. The enhanced biological nutrient removal, they take that first clarifier, and we're going to grow some bugs in the bottom that are really old, really fermented bugs, and then inject them into the process later on to eat
bugs
after they've already kind of gone through a couple times. Yeah, I know. It's cool stuff.
Yeah. And there's a phrase on that's stuck in my head when you're talking about this, adding phases. I feel like somebody said they're on skids. Am I understanding correctly that essentially like you build the plant, so you're like, no, these are the first 2, and then the other 2 will slide in right here, and it'll just be in line, essentially just pump it, like we're going to just extend the pipe, and then they'll like add the next 2 and keep going?
Not as much. That's our neighbor Star. They have a membrane plant, and that's kind of how they do it.
Gotcha.
That's okay. Our operator describes that as the Keurig model of wastewater treatment plant.
Yeah. That's the idea.
You kind of go get, you saddle up and you say you want the Keurig model. You got to buy their pods every couple of years.
So you have more repetitive cost, even though the upfront cost might be a little bit lower.
Right.
Yeah.
So
that's an old school business method.
There you go.
Like everybody knows that. Did you know that's the King and Cork actually? They were the bottle cap makers, right? So the bottle cap. The one they would give away the machines for free. So all of these bottle manufacturers that, or bottling companies that were using corks were like, oh, we have this bottle cap now. And they'll give it to us for free. But each bottle cap was 1 cent. So it's like you get the upfront cost down low, but then the operating cost over a long period of time. That's actually HP, 70% of their revenue just comes from printer cartridges, or at least did about 10 years ago. I don't know if they've modified their business model, but
not to disparage that treatment technology.
No,
it's a great model. It works great in lots of places.
Star's just about to get hosed. It's fine, whatever.
Yeah, whatever. So it's just wasn't right for us.
Sure.
So they're not much of a cost difference really in the long run of what we're looking at. We're just going a different route. Sure. So that's the route we're on. We're looking at what we need to build for right now. Our current plant has the capacity of about 1.7 million gallons per day. Okay. Like I said, we process about 0.9 million gallons a day right now. So we're at about 60% capacity.
But not at the right chemical output.
Not at the right, that's the point to make, right?
Got it.
Not at the right, now, when you look at sizing wise, okay, 1.6 million gallons equates to about 8,000 homes. We have about 5,000 homes being served right now. The other 3,000 homes have been platted. They're somewhere in the process of somewhere between
after approval,
first approval, to being constructed, to actually getting a building permit, to actually having someone move in. So we had about a year and a half ago, we said we just don't want to accept residential annexations. We don't want to bring more people into the city, more developments outside, just based on our sewer capacity. Because last thing we'd want is somebody to get a building permit, get their home built, and we say we can't serve you sewer.
Yeah, right.
So,
right.
That's a pretty conservative approach across the valley of saying we want to make sure we've got that capacity. And we really had to, because the plant we had just couldn't be expanded. You couldn't add another something down there. Now that we're on this other path, we're going to where we'll be able to add another clarifier, another basin, another UV module at the end, and be able to accommodate things as they come in. So it's a responsible approach, as I think what we've glad to tell the community that we've done is set us up well for growth as it comes.
Right. And again, to be clear, you're not just doing that for funsies. Like, you are required to overbuild this mechanism so that, in a year, you're not coming back and saying, okay, we have to add on. Because, that's just poor planning. And then obviously from a financial standpoint, that would be a horrendous decision, because you'd have to essentially keep busting out. It's like, it would be like adding 10 square feet onto your house at a time. Yes. It's like, you're not going to redo the roof line and the fountain. Can you just overbuild? You have 3 little kids. They're going to be giant. Well, at least I do. Yeah. So it's like, we got to give them space, and that's responsible planning.
Yes. Hopefully we've been responsible. That's what we'd like to communicate, is we've been responsible. We've done our best to be responsible.
Now, look, say you get crazy and you're like, hey, man, I ain't doing this no more. And people were like, what? What do you mean? You're like, I'm not building anything. And they're like, I think you should. You're like, I don't care, because I'm a wild man. What happens? Like, if Middleton just decides, like, we're going rogue. You remember that Sarah Palin book, Going Rogue? My dad was living in Alaska. He loved Sarah Palin. Thought she was great. Anyway, so like Sarah Palin style, like, I'm going rogue. Okay. Like, I don't care what you say. Then the state regulatory body, right, the Idaho Department of Environmental Quality, they're like, hey, man, this is okay. You've gone rogue. Good for you. Like, kudos. Great for Instagram, whatever. This is what actually happens to you now. So, like, what happens if you guys don't abide by this?
So we get fined as a city. There are cities that are in trouble for not complying with their process. Eventually, they get into a consent decree that says the government makes you set aside this much money to do this, to somehow get in compliance with our requirements.
Do the county commissioners of Canyon County essentially like take you into conservatorship at some point? I'm sorry, I know this is very technical.
That would be a ways down the road.
Okay.
Of your city would have to like default and go away. I think a city did go away here in Idaho not too long ago, because they just couldn't make it, and then their assets just kind of go to the county. But
because they have these large public works, and then they can't, the incorporated entity that was managing them is insufficient, so then they get absorbed by the county.
I think.
Gotcha. So the bottom line is, like, you can refuse to do it, and then you lose a lot of money in the near term.
Yeah.
And in the long term, you end up having to spend the money anyway.
Yeah.
That's pretty intense.
Yeah.
And now, mind you, this is not, when people get bothered in the, like Starfire District, everybody's like mad. Growth should pay for growth, all these things. Yeah. This issue and the requirement of like, hey, you need to be 1/50th of what you are, that came out in 2015. And it sounds like you guys were about 750 or 7,500 in population between the 5 and the 10 in 2015. So this isn't necessarily like, oh, growth, it has spurred this revision. It's no. We even have another 3,000 home capacity. We're at 5,000. We could go to 8. That's not the driving force right now. At some point it would be.
No.
But the driving force right now is state requirements that changed. And now we have to modify this thing. So when people are like, growth should be paying for growth, it's like, yeah, that's all well and fine. Has nothing to do with this right now.
Yes.
What we are talking about are environmental quality regulations that changed like a decade ago.
Yes.
And we are now catching up to it. So yeah, be mad at the person who moved, say, from California. That's fine. Be mad at them. Has nothing to do with them, because these requirements changed, and the number of people here is irrelevant at this point.
Largely. Actually, the more people they have, more people help pay down the plant. But we'll
So
not go there.
how do you attract more people to Middleton? Go the star route.
Yeah.
Go the star route. They're plenty happy.
So let's
Said no one
let's
ever.
take that a little bit aside. How do we get the money for this for this and kind of in contrast to the schools, the state has a provision where if you have to do something for your sewer plants, you can get what's called a judicial confirmation.
You don't have to ask the people.
We don't have to ask the people.
That's why everybody's mad.
That's probably one of the reasons. Okay,
So that's why you don't have to go hat in hand to the voters and say, "Hey guys, we need to upgrade this thing." They're like, "I don't care."
We
Like,
sure
I don't
could.
care. Yeah.
You could. Napa had a campaign the other day that said that a couple of years ago that said, "Do you want to do this, or should we just raise your rates enough to do it tomorrow?" And they passed. But yes, our council looked at it and said, "Well, we're probably not going to pass."
Because you've had such great success with school bonds.
Yes, and heck, you and I, we like wastewater treatment plants.
I mean, actually, I kind of do now.
Yeah, I do, and I wouldn't vote for it. It's not fun things. It's not yay. It's helping the river a little bit or a lot, depending on who you ask. But the process is if you go to the judge and say, this is ordinary and necessary for cities to do, and necessary being we have to do it, he can grant that authority to the city, which happened recently. So
That's like cruel and unusual.
It is
ordinary and necessary.
Yes. So that's where we're at with this first expansion. We were doing an impact fee study, which is the way Idaho is set up to have growth pay for growth, where we will quantify the cost to add one more unit and then charge that to people as they come in. That's different than a connection fee. An impact fee pays for the future growth. A connection fee is you have 5,000 people that have paid for a system that treats 8,000 people's worth of water. So that one 8,000th that the new connection comes in is paying back the people that are already there for their investment in that system today.
But again, to be clear, this is still not a growth threshold problem. So like you have an impact fee and there's going to be some manner of financial obligation with hookups. So totally fine. Like awesome. But this is not spurred because of development. This is state regulation changing.
Yes.
Man, that's really interesting. I had no idea. I mean, obviously that's why I invited you in here to understand it better. Yeah. And this goes across Idaho, I presume. So like everybody has to be at like the 0.1 in the summer and the 0.3 in the winter.
It's that is for the Boise River specifically, lower Boise River. So really from Boise down to maybe Fruitland. I don't know if Fruitland's in there or not.
Okay.
Yeah,
but again,
Parma's in there.
Was this determined with the water board as well, or was this really just the Department of Environmental Quality considering all of these things?
It was a little before my time. So
gotcha.
Not they did the Department of Environmental Quality. My understanding is they led the effort, but they got a lot of input from the Lower Boise Watershed Council, which is a group of kind of all the users in the valley.
I wonder if Paul Arrington with the Idaho Water Users Association, I wonder if he would have some background on this, or maybe his predecessor, Norm Semenko. Yeah. Because it seems like something where it is a really big ask, right? Like you're requesting a lot from these municipalities to upgrade their systems. Yeah. And it's kind of like, okay, this is really necessary. This isn't a want, this is a need. And okay, can somebody explain to me the need? Because you're just saying like, hey, look, these are the regulations. Nobody asked me, I wasn't even here, whatever it might be. But I wonder, who would I ask to be like, hey man, this is costing the Treasure Valley, let's say $500,000 collectively, right? And that's a lot of money to pull out of the Treasure Valley. It's got to be more than that. Because if you guys are like at, let's say 100,000, I know you're a little bit over, but if you're at 100,000 with only 10,000 people or 13,000 people, like Nampa would have to be like 400 million or 400,000 or something.
Nampa just made a huge investment in their plant.
Okay.
To the tune of in excess of 100 million.
Okay, so this is costing,
yes.
this regulation shift is
Yes.
costing the Treasure Valley, let's say $3 million.
Oh,
At
3
least.
billion?
3 million, 3 million. Like
It's costing Middleton like
60,000.
million.
60 million, excuse me.
Yeah.
So we're looking at billions, 3 billion, $4 billion ish. We're spitballing.
Sure. Yeah.
Okay. Because you have Meridian, you have Nampa, Caldwell's close behind, and then you have, obviously Boise. And like Meridian is the population.
Meridian, I just got a tour of their treatment plant. They're way under construction, spending.
Dude, how much did that cost? Do you have any idea?
I don't.
Oh my gosh. Okay. So the point is billions.
Yes.
This is costing billions, and understanding that it's like, okay, what was the ask? What was the need that so necessarily justified or required this thing?
Yes.
So it would be the IDEQ, the Department of Environmental Quality, or somebody who was working or could understand the history. Yeah. Okay. Man, I'm going to have to get these answers. It's going to be good. Are we missing anything?
It's temperature.
Yes, that's the other thing, because you can't dump in a lot of hot water or water that's off temperature for the river, right?
That's right. The temperature is a concern on the Boise River. That's right in state statute. We anticipate some regulations on the horizon of how we're going to address that. Right now, when we've talked to IDQ, it's let's see what the new plant temperature comes out of that plant, because it's probably going to be different than what comes out of our current plant. Let's look at the real gem of our alfalfa process is if we can be putting water over there and not putting hotter water in the river.
And not spending the energy to cool it.
Right. And
so
not
you get,
the energy. Right.
If you're a foot underground, you don't care if it's a little bit hotter or a little bit cooler. It doesn't matter to you guys.
You would think it would come out before it migrates to the river channel, right?
Yeah. Oh, yeah. The heat would get zapped out. Right. I mean, like, how hot is the surface of a field in the summer, right? Like, obviously, that heat is not transferring the same way. Right. So that's a huge cost saving to you guys, cost and time and infrastructure, if you can just export that, slightly elevated temperature water to an alternate location that would then zap out not just the phosphorus, but also the temperature.
Yes.
Look at you.
Hey.
Somebody was thinking about this.
Hey, well, I'm glad to be part of the group.
That's awesome, man. Cool. So that's a big piece.
That's
Anything
a big piece, yeah. So we have some fields actually near our treatment plant that will line up really well for that. Are
these already growing? Are you already doing alfalfa?
We're doing alfalfa on our little 10 acres.
Yeah.
We have another 60, 70 acres that we just let a farmer kind of grow stuff on for right now. But we're getting a plan in place with Department of Environmental Quality to do a full recycle plan, which would kind of make us an official, not just a study, to expand out into some of those areas. Man,
if you do get that and you go under construction, I'd love to come out and see like the capillary tape and everything, because like that seems wild to me. And again, as a layman, it's really cool to see the spoils of industry and, frankly, capitalism just come into play, where it's like somebody thought up this tape somewhere in the world. And I'm sure it's like, we're not the first ones, but like, then it's like you always have it's like the floor underfloor heating things, right? It's like when they first came out, years ago, they always broke and they never worked, and then they get better and better and better and better. Now it's like, bulletproof, right? It's like the tiles themselves heat up and you just connect the tiles or something with grout over it. They have something like that. Yeah. But anyway, I'd love to see it if you guys
would love to have you out.
Yeah. Awesome. Well, listen, man, thank you for coming out. Thank you for explaining this.
You're welcome.
I hope, like I was curious about it, but whoever in Middleton listens to it, I hope it answers some of their questions too. Cause like, good Lord, I don't know under what circumstance I would have learned all this. So I can't imagine that there are a lot of, easy to consume mediums that people can grab it from. So
it's a complex subject. We're happy to explain it. Please come in. Folks want to know more. Knock on our door. We're only so many people. I'm glad to talk to all of them.
Dude, nobody's coming to the door. Nobody goes and knocks on the neighbor's door. They go straight to Facebook and complain about it. It's like, it's your next door neighbor. Just go talk to the person.
And go sign up for a tour of the plant, because those guys, they're done by themselves all the time, and they love having somebody to talk to.
Like,
but
someo's here.
Yeah.
It's like that scene from Cars. Remember that cartoon? It's like, travelers, everybody take your place.
Yes.
Never need a map again. Got the GPS. That's great. That's great.
Hey, thank you for your work you do here.
Yeah,
Thanks for
absolutely,
the
man.
opportunity to come on, and we'll look forward to doing it again sometime.
Yeah, absolutely, man. Thank you very much. We'll see you soon.